Hi guys, my name is Peter C. Dogba Jr., math instructor of the University of Liberia and your math tutor. In my today's lecture, I will be looking at proof of the properties or the rules of differentiation. So to begin with, we want to look at the proof of the constant rule. And we know that in derivative, the derivative of a constant is equal to 0. So why is it that is equal to 0? What are the processes that leads the derivative of a constant to be equal to 0? We're just going to look at that now. To prove that, we're going to use the first principle of derivative that we derived in our previous videos. So you can check the other videos and you will see that we did derive the first principle of derivative, or the definition of derivative using the limit process. So we're going to use that definition now to carry on the proof of the constant rule of differentiation. So the first principle of derivative says f prime of x equals to the limit of f of x plus h minus f of x divided by h as h gets closer and closer to 0, or as h is approaching 0. So with this now, note that before you differentiate, the first thing you must have is a function. So what you are about to differentiate is called the function, right? So this indicates the derivative. It indicates that you are about to differentiate this function called c. So we can say let f of x equals to the function that we are about to differentiate called c. Now, we know that when a constant is just standing alone, there is an invisible variable, and the variable under consideration here is x. So there is an invisible variable attached to that constant, and that variable is raised to the power 0. Because we know from the laws of exponent, if you have x raised to the power 1 divided by x raised to the power 1, and you want to use the laws of exponent, that states that if you have x to a divided by x to b, this is just equal to x to the power a minus b. So we can apply that property here and say 1 minus 1, which is x raised to the power 0. So we know that x into a is one time, x into a is one time. So this is just 1 equals to x raised to the power 0. So it's proving that x raised to the power 0 is equals to 1. So c times x raised to the power 0 is nothing more than saying just c, the constant c, right? So in this case now, we can clearly use this function that we have within this limit process. So now we say f of x, what is our function? Our function is c x raised to the power 0. And what is our f of x plus h? Because these are the two things that you need to know to replace within this function so that you can solve for the limit of this particular function. So we know f of x, which is the original function, cx to the power 0. And we now want to find f of x plus h. So in this f of x, we have to replace this x now with x plus h. This is x plus h. So on the right hand side, wheresoever we see x, we're also going to replace it with x plus h, x plus h. But it is raised to the power 0, so we put 0. So we now have f prime of x, the definition of limit. The limit f of x plus h, we know that this whole thing is just equal to this. So we replace it, c x plus h raised to the power 0 minus This whole thing is just c x raised to the power 0 all divided by h, as h is approaching 0. So we now have this now to be equal to the limit. Now, x plus h raised to the power 0, we told you anything raised to the power 0 is equal to 1. So this is just c times 1 minus, this is also c times 1 all over h as h approaches 0. So we clearly see that f prime of x is just equals to the limit. C times 1 is just c. C times 1 is c. So c minus c is 0 all over h. The limit of 0 all over h as h approaching 0. So the limit of 0 over h is just equal to the limit of 0. And since 0 is a constant, we know that from limit, the limit of a constant is equals to the constant. So we have f prime of x is equal to 0. Thus, we say d by dx of a constant is just equals to 0. That is, any constant you have, whether 5, -10, the derivative of the square root of 5, the derivative of 1 over 2, whatsoever constant that you have, when you take the derivative of that constant, it goes to 0. So thanks ever so much for watching. See you in our next video, wherein we will explain, we'll solve some problems on finding the derivative of a constant using this particular formula we've just gotten. Thank you very much.